So, don't have time to go into what's been happening with all of the science, but I really can't miss mentioning that we've actually seen the Arctic ice melting and disappearing at a really rapid rate. And that has implications for things like permafrost melting in the Arctic areas, and also sea level rise in terms of that Arctic ice melt actually makes the feedback effects make the Arctic warm up even more quickly, which warms Greenland up even more quickly and melts Greenland ice sheets even more quickly, running into the oceans and contributing to sea level rise. 50% of the Arctic ice volume has melted already, and there's actually very clear indications. The graph there shows the black lines as the model projections of how the Arctic was supposed to melt over the next 100 years, and the red line is showing what's been happening over the last few decades. And that record melt last year was smashed the previous record right out of the ballpark. There's actually every indication now that we'll see a largely ice-free Arctic over the northern summer sometime before 2020. It's a very, very, very real possibility. So we see continued global sea level rise, and so the graph there, the orange line is the tidal gauge record going back several decades. The red line is the satellite sea level rise measurements, so two independent measurements of sea level rise, and they're showing consistent sea level rise over the last few decades of about 3 millimetres per year globally. And at those coloured lines there are the projected sea level rise from some of the IPCC reports, and once again right at the top of the global sea level rise measurements. What are we seeing locally? So that's a map there of the Bureau's National Tidal Centre baseline monitoring gauges from around Australia. So there is regional variation, but those figures are millimetres per year, averaged across the life of those gauges, which they were all typically installed in the early 1990s. So they've been there for 20 years, measuring sea level rise quite accurately. And we're seeing for South Australia between about 4 and 5 millimetres per year every year for the last 20 years of sea level rise along the South Australian coastline. So that adds up to about 8-9 centimetres of sea level rise, coming on top of about the same again over back through the bulk of the 20th century. So we are seeing significant sea level rise. If you increase sea level by about 10 centimetres, you get about a doubling of storm surge frequency, and that's what we're seeing in the South Australian record. That storm surge events have basically roughly doubled in frequency since about the 1950s. I'm going to talk a little bit about natural variability. I've spoken about La Nina events and El Nino events, and so they're a major feature of natural variability that impacts our climate system globally and in Australia. And it'll become clear why I'm doing that, but essentially El Nino events, we see a warming in the middle of the Pacific Ocean, which you can see in that top map there, warmer than average temperatures in the middle of the Pacific. The oceans around Australia tend to be a bit cooler. In the opposite phase, La Nina, we see a cooling in the middle of the Pacific and a bit warming in the oceans around Australia. Now they tend to kick off through about winter or spring and last till about April the following year. So they tend to last for about a year. They change rainfall patterns, so in El Nino events we tend to get drier than average conditions, as you can see the red in the top map there. In the 2006 El Nino event. In La Nina events we tend to see wetter than average conditions, and that's a map from the 2010 El Nino event, so which occurred through spring and summer 2010 into early 2011. So we saw major flooding across much of Australia, particularly the eastern states. So the eastern states tend to get impacted a bit more strongly than us, but certainly really significant event. Now this La Nina event was arguably the strongest on record, and if not the strongest, it was right up there in the top sort of 3 or 4 that we've ever seen across the record since about 1880. So yeah, it's really important to keep in mind that climate change, we don't stop seeing natural variability. We're always seeing a combination of the two. We are seeing longer term climate change trends with wiggles in there from natural variability through things like La Nina events, El Nino events, and other influences such as volcanoes, solar activity, and some of those other things I mentioned. So it's not one or the other. We can't be misled into thinking that because things have gotten a little bit wetter for a few years, or perhaps not warming as quite strongly for a few years, that climate change is not happening. We need to be very, I think, very conscious about making sure that we make that message clear to people that we're engaging with and working with. We are talking about changes that are going to play out over centuries, so over decades and centuries and even thousands of years. So we are determining the state of the climate over the next several thousands, even tens of thousands of years. So this is not going to go away, and we can't allow variations from natural variability to sort of confuse action and the messaging that we're putting out there. But the other thing is, probably the other key message I'd like to get across is, in terms of trying to determine what's going to happen over the next few decades or even 100 years, and how we're going to respond to that, we want information, and we would like to know that as accurately as we can. The trouble with climate change is the basic science is very well established. That the global warming trend, and to a degree the global changes in global rainfall, increased rainfall in the tropics, drying in the mid-latitudes are all very, very well established, and the science is very clear on those. But in terms of regional changes, in terms of what may happen down to the decimal place, are we going to see 1 degree of warming by 2050, or 1.5 or 1.34, or we'd like to have that sort of accuracy of answers, but we're probably not going to get that out of the information that we have available. There's certainly work going on continuing to try and improve the accuracy of the information we have available, but this is a clear example. We really don't know yet what's going to happen with El Niño and La Niña events under climate change. The science there's been a lot of work going on trying to pin that down. The models actually don't represent them as well as we'd like. The latest modelling has improved that slightly, but not nearly as much as we'd like. So this is a strong natural influence on our climate system that the models don't represent very well yet. And as we can see in these maps, has a very major influence on rainfall patterns across Australia. We don't know yet or not whether there's a multi-decadal cycle in the frequency of La Niña and El Niño events or not. There may or may not be a 30-year cycle, varying how many El Niño events or La Niña events we get. Is climate change making them more intense? And there's actually I think some reasonable evidence indications that when La Niña events occur, such as this La Niña event that we saw in 2010, that the increased moisture availability in the hydrological system is making made that event more intense than it might have been otherwise. So we're seeing natural variability starting to be influenced, or maybe even more extreme, by climate change. So there's these sort of wrinkles in there about, it's not just climate change or natural variability, it's not just climate change and natural variability, we're seeing climate change impacting our natural variability as influences as well.